Real important. Today we're going to talk about, for this lesson, we're going to talk about a rhombus. All right, now a rhombus, guys, is a parallelogram. And so because of the fact that a rhombus actually is a parallelogram, we got to keep in mind the 5 properties that exist with the parallelogram. So here's what we know. We know that this side is parallel to that side. We know this side is parallel to this side. Opposite sides are parallel. That's a parallelogram. We know that this side length and this side length are the same. And we know that this side length and this side length are the same as well. Opposite sides are congruent in a parallelogram. We know this angle and this angle are the same. We know that angle and that angle are the same. Again, this is all just properties of a parallelogram. So how many do we have? We have 1, 2, we have 3. We need to know this. This angle here plus this angle here, or consecutive angles, are supplementary. And then the last thing that we should have is that this diagonal right here and this diagonal right here, they bisect each other, meaning that that length and that length are the same, that length and that length are the same. Okay, so all these things are just the properties from a parallelogram. Now, when we're talking about a rhombus, here's where things change just a little bit. The important thing about a rhombus, or the big idea, is this. All 4 sides, now I erased a little bit of my side, that's all right. All 4 sides of a rhombus are exactly the same length. So there's the big difference between just your regular parallelogram and a rhombus, okay? All 4 sides are exactly the same length. A couple other things that we need to note. The diagonals of a rhombus will intersect at a right angle. So all 4 of these angles right here are 90 degrees. And the last thing we know about a rhombus is that the diagonals are actually angle bisectors. In other words, this big angle and this big angle are the same, and those are the same right there. Also, this guy right here has been cut in half, and that guy right there has been cut in half as well. Okay, so just 3 extra properties. All 4 sides are exactly the same length. The diagonals bisect at a right angle, so all 4 of these angles are 90 degrees. And also the diagonals are angle bisectors. Let's put some algebra behind this and find some lengths. Okay, in order to fill in all this missing information, here's what we need to know. Here is a diagonal shooting across the distance of this particular rhombus. I guess before we really even start this particular problem, you need to know this, the fact that it is a rhombus. So let's do this. All 4 sides are the same, and opposite sides are also parallel. All right, now that we know that, now we can go about applying the properties. Here's what I know. A diagonal, okay, a diagonal does what? We know it intersects at 90 degrees. We also know that it is an angle bisector. So if this measurement right here is 44 degrees, that means that this measurement right here must also be what? Dead on, 44 degrees. Opposite angles, okay, opposite angles in any parallelogram, and again, a rhombus is a parallelogram, just more unique, they are congruent. So if this side is 44 and 44, what do you think this guy is? You decided 44 and 44 were right? Dead on. Now, in order to find Z and W, we're going to have to apply the fact that consecutive angles, or this whole angle over here, the whole big boy, that angle right there, plus this angle right here, we know that they have to add up to what? Both of those two have got to be 180. So in order to find this now, let's do this. 180. Okay, now we got to take away what? Well, this entire angle right here, guys, is not 44. The entire angle is both of them. So it's actually 88. So let's subtract away 88. So when I do that, we end up with 92. So the entire measurement for this whole guy right here is going to be 92 degrees. However, W is not the whole angle. W is only half of it. So what we need to do now is we need to take the angle that is 92 and divide it by 2. And we find out that each of these angles is actually 46 degrees. So again, using the properties of a rhombus to figure out missing information. So let's take this. We're going to do this one problem at a time. All right. So here's the information that we have. What do we need to find? First thing we know, this shape right here that is RHOM is a rhombus. So all the properties that we've talked about, they do apply to this. We know that the distance from R to H, as given information, is actually 2x plus 18. Again, I highly suggest to you guys, write the information onto the drawing that you have. It makes things a lot easier to see. We also know this. RM is 4x plus 6. So RM lives over here. Now what we're asked to do first off is we need to find x. So let's just stop right there and find out what x is. So because of the fact that this shape is a rhombus, we know that this side and this side and this side and this side are all the same length. So because of that, this is equal to that. Set it up just like I said it and solve it. Now, variables are on different sides, so we need to get the variables together. So bring the 2x over. Now get the variable alone. And the last thing is divide by 2. So again, now we've done the first part right here. We have found out what x is. Now we need to determine what is the value, or what is the length of RM or RH and OM. Take the value that we have for x and go ahead and plug in this information. So here's what we know. Let's do right here. 2 times 12 plus 18 . And so now we have this, 24 plus 18. And we find that the length of RH is 42. And again, what do you know about the lengths of all 4 sides of a rhombus? They're all the same. So all the sides in this case are 42. And 42, what you might ask? Units, because nothing is given to me as far as that information is concerned. Let's take a look at this other problem right here. Again, I know that we're dealing with a rhombus. And how do we know that? Again, that's given information. So because of that, we know this, that, and that. Okay. We also know this. We're told that the measure of MBO. So where is MBO? MBO lives here. MBO. So we're actually talking about this angle right here. And the expression that we're given for that is 20x plus 50. Now, MBO is the place where the two what? Diagonals intersect. And one of the properties of diagonals intersection within a rhombus is that they always intersect at a right angle. So this expression right here should equal what? It better equal 90 degrees. So 20x plus 50 is equal to 90. Now go about the process of solving to get the variable by itself. So subtract 50 away. And last step, divide by 20. Now, are we done with this problem? You bet. The problem only asked us to find x. I just found x, and then that's the end.